Welcome to episode 13 of George's Random Astronomical Object. Every episode, I run the random number generator to select random astronomical coordinates in the sky, and I then search for an astronomical object near those coordinates and spend a few minutes talking about what makes that object so interesting to astronomers. So let's run the random number generator. The generator has returned the coordinates of 13 hours, 31 minutes, 19.5 seconds right ascension, and negative 54 degrees, 58 minutes, 34 seconds declination. This points to an object called BV Centauri. Now, when I started looking into this, I realized that some of the people that I work with at the Jodrell Bank Center for Astrophysics know much more about objects like BV Centauri than I do, so I decided to ask one of my co-workers if he could give a description of this object. Here is Mark Kennedy.
BV Centauri, or BV-CEN for short, is a system located in the constellation of, unsurprisingly, Centaurus. It was first noted in a paper by W.F.H. Waterfield in 1929 as one of 25 new systems in Centaurus which showed variability. Since then, it has been confirmed to belong to the U-GEM subclass of cataclysmic variables. There's a few phrases in there which are likely unfamiliar, so let's start with cataclysmic variables. These are binary star systems which have white dwarf primaries that are stealing matter from a nearby companion star. They are often subdivided into further classes based on what the matter is doing. For example, the behavior of systems whose white dwarfs have very strong magnetic fields is very different to those whose white dwarfs have negligible magnetic fields. There are over 1,000 systems known to belong to the cataclysmic variable class, with the majority of them being classified as a U-GEM system. U-GEM stars are named after the archetypical system U Geminorum. In these systems, the material which the white dwarf steals from the companion forms a disk of material around the white dwarf. Once this disk has built up enough material, a thermal instability is triggered, which causes the disk to dump a lot of matter down onto the white dwarf. This results in the disk becoming very hot, meaning we see the system brighten by up to 3 magnitudes at optical wavelengths. These brightenings are called dwarf nova outbursts, and are very different from nova outbursts, during which thermonuclear runaway occurs on the surface of the white dwarf and the system brightens by many more than 3 magnitudes. BV-CEN is one of these systems. Typically, it varies between an optical magnitude of 12.9 and 13.3 over a timescale of 14.6 hours. This variability is caused by the movement of the accretion disk and the companion star around the white dwarf over the orbital period. On top of this variability, the system regularly brightens up to a magnitude of 10.7 every 150 days or so, which is due to the previously mentioned instability in the accretion disk. So out of the many cataclysmic variable systems that are known, why is BV-CEN interesting? Its white dwarf has a mass around 0.8 that of our Sun's. This is a completely bog-standard value for the mass of a white dwarf of a cataclysmic variable, so it's not that. What about its orbital period? Since the separation between the primary and secondary star in a binary system is dependent on the orbital period, we would expect that systems with short orbital periods, meaning the stars are very close, are the most likely to interact and produce dwarf nova outbursts. This turns out to be true, with the majority of cataclysmic variables having an orbital period that is less than 8 hours. At 14.6 hours, BV-CEN has such a large binary separation that we would not expect the white dwarf to be stealing material from its companion, meaning it should not show outbursts. And yet it does! This has led some researchers to believe that thermonuclear runaway occurred on the surface of the white dwarf sometime in the early 1900s. This eruption would have led to the companion star being subjected to an intense amount of radiation, causing it to inflate and begin the process of mass transfer. As such, the very rare long-period cataclysmic variables, such as BV-CEN, are key in showing us how nova eruptions and dwarf nova systems are related. There is also another reason BV-CEN is an interesting object. It is one of a few systems which researchers have been able to accurately reconstruct the surface of the companion star. This has been done by acquiring optical spectra of the system, isolating the features of that spectrum, which we believe come from the companion star, and then, much like facial reconstruction, these features were used to build an image of the star's surface. The results are quite striking, as they show that a large fraction of the surface of the star is covered by star spots. These observations have helped reinforce the idea that the companions in cataclysmic variables are magnetically active, and more importantly, that this magnetic activity will have a role to play in the system's future evolution. This is due to the fact that the number and location of these spots on the stellar surface is likely to change as the companion star goes through its magnetic cycle, which will directly impact how mass is transferred from the companion to the white dwarf.
That was Mark Kennedy with a description of BV Centauri. The place on the Earth's surface corresponding to the location of BV Centauri in the sky is a part of the South Pacific Ocean, 2,500 kilometers southeast of New Zealand. I really tried looking up information on this location on the Earth's surface, and really it looks like the type of place that nobody would want to go. I don't even imagine fish going there. It's that boring. And there are no underwater geological features that are terribly interesting either. It's just blank ocean. Well, in any case, the website for this podcast is www.randomastronomicalobjects.com. You can visit the website to download episodes of the show, read information about the astronomical objects, view images of those objects, and send me random feedback. My special guest this week was, once again, Mark Kennedy. The audio was recorded and edited by George Bendo. The music is Immersion by Sasha Endy at www.sasha-endy.de, which is distributed by filmmusic.io under a CC 4.0 attribution license. The sound effects are from the Free Sounds Project at www.freesounds.org. Thanks for listening.